Like most things in the world, if you assume they're simple and you ignore the details, you can cause a lot of damage. This is why it can be dangerous to have politicians or uninformed activists take up a cause like recycling. Not to say that we shouldn't recycle, we absolutely should. But there's a lot more at play than just virtue signaling here, and there are some factors that are dangerous to overlook. There are some real considerations to take into account, and if you fail to do that, you could cause some real problems. As they say, the devil is truly in the details. Now, there are certain plastics that if you mix together and apply heat, you can create a chemical reaction which has some really nasty outgassing. And I feel it's also important to point out that this is not exclusive to plastics. There's a whole lot of things that if you mess with, you could have some dangerous results. Now take, for example, the metal magnesium. If you take this element and you drop it into water, you will have an extreme exothermic reaction. So, in other words, very dangerous. There's also household chemicals that if you were to mix together wrong, you would have a very bad day. Not to mention things like gasoline, which we interact with very regularly, but oftentimes we disregard how dangerous that really is. And I guess the real takeaway is, regardless of whether you're working with something like magnesium or gasoline or even plastics, that it's important you understand what you're interacting with. And that's why I'm so happy you're here today learning about the world of plastics. Let's check it out. Now here's something a lot of people don't know about the world of plastics. But the material that is used to create a product is often used many times at the manufacturing facility, way before it ever shows up in your hands. And that's done right here at the factory. So let's look at this as an example. This is a cold runner mold. And like a lot of molds, the plastic actually enters into this mold right here at what we call the sprue. It has to enter in and flow around various components in the path that we call the runner. And when it gets to its final destination, it will enter in the cavity in a path that we call the gate. So you can kind of visualize how this might set in your mold. Plastic will flow down the sprue through various obstacles down the runner and then actually enter your component. Now what that means is every time we make a part, we also make one of these things. Now even though this is created from 3 distinctive sections, we generally just call this a runner. But we don't just throw our runners out. Oh no, this is good material and it costs money. And remember, everything is driven by economics, and it drives this too. Now in a capitalist world, we're constantly trying to squeeze value out of everything we touch. And that applies to our little friend here as well. We will grind this up and reuse it down the road in a process that we call post-industrial reclaimed material, or PIRM. Now, some applications will allow us to grind up that material and reintroduce it into the same production. We can just introduce it into the material flow and we're good to go. Other applications require that we only use virgin material. But even in those cases, we can grind up those runners and use them in other applications down the road. Now, there are a lot of different reasons for that, but let's start with the lot number. Now, lot numbers are used in all kinds of different applications, from chemistry to yarn that's used for knitting. But the basic idea is that you apply this number to hold a whole bunch of different parameters. That could be the manufacturing date, the equipment that was used, maybe the operator who was running that particular batch, or it could be the chemical lots that were used in the manufacturing process. But regardless of what the specific manufacturer is recording, it all boils down to one lot number or batch number, like here. Now in most applications, a bunch of different components are all brought together into one final assembly. Think of a car as an example. Now a good manufacturer is going to record the lot number of each of those components into their final assembly. So if there's ever a problem, they can simply pull up the lot number of the build and track down to who manufactured that particular component. Now, problems occur for all kinds of different reasons. Let's say it's cracking, for example. That might be a UV exposure. And that can come from a poor mix of UV additives in the material. So a manufacturer might want to track that down. They will first look at their internal processes to see if maybe they're screwing something up internally. And if that fails, they will go to their vendor and say, hey, we're having a problem, can you check your process? And it just keeps on going up the chain. It will continue to the point where somebody no longer has a lot number of their vendors. At that point, that particular vendor actually holds a lot of liability. This could be an expensive fix, and without data, they're kind of left holding the bag. On the other hand, lot tracking also costs a lot of money, so kind of a give and take sort of situation here. Now, for life-critical applications, it's really important to have lot tracking because you very much want to get to the bottom of the problem. Now, if you're making something like a trash can lid, maybe it doesn't matter so much. So if we are running a critical application where we want to maintain lot tracking, then we will use what's called closed-loop PIRM, which means that the materials that are introduced into that production run stay very localized right in that machine area, and they don't travel throughout the factory. In other applications where it's not so critical, then we will just mix the materials together into a larger batch and reuse them for just your average, everyday PIRM sorts of applications. And there's nothing new to this process, nothing at all. We, in fact, have been doing this since about 1983. Now, capitalism and manufacturing generally get a bum rap because there's this perception that they always prioritize profit over the better good. But actually, it's capitalism that encourages these companies within the United States to make the right choices. What is good for the economic good also tends to be good for everybody involved. Capitalism is what makes this whole thing work. And as I've said before, if the economics of it don't work, none of it works. Well, that's all I've got for you today. But make sure you come back and check out the channel later because we're working on some really cool things. Don't forget to like and subscribe so you can get all our latest content. And remember, go out there and do something cool today.